Good morning, everyone. We're broadcasting live from the basement here in the Conway Institute. It's my pleasure to introduce our first speaker, Professor Seamus O'Mahony. Seamus is a physician and author. Until February this year, he was consultant gastroenterologist and clinical professor at Cork University Hospital. His first book, The Way We Die Now, won a British Medical Association Book Award in 2017, and his second book, Can Medicine Be Cured, was published in 2019. He's currently visiting professor at the Centre for Humanities and Health at King's College, London. The topic today is about medical research. I think we often consider medical research as an unalloyed good and don't think too much further about it. Hopefully, Seamus today will give us a kind of an overview of how he sees the field over the last number of years. Okay, without further ado, I welcome Seamus.
In the very first episode of The Sopranos, Tony expressed some regret that he had missed the mafia's best years. And I feel a similar regret over the timing of my career in medicine. I qualified in 1983. Now, because I can't use a pointer for this presentation, I should tell you that I'm the one on the left. And there I am with, this is 1983, head full of hair, heart full of hope. And I graduated towards the end of medicine's golden age. And I've arbitrarily defined this as lasting from the mid-1930s to the mid-1980s. My first ever presentation at a medical conference, a major medical conference, was at the British Society of Gastroenterology in 1987. And this particular meeting marked the 50th anniversary of the foundation of that society. And every delegate was given a copy of this book, which contained a selection of the most influential gastroenterology papers over that previous 50 years. Predictably, the book was sponsored and paid for by a drug company. The introduction to this collection was written by Sir Francis Avery Jones, grandest of the grandees, and by common consent, the father of British gastroenterology. The first meeting of the society in 1937 was a dinner at the Langham Hotel in London with 36 founding members, all male. Sir Francis was present at the first meeting and was guest of honor at the Jubilee meeting in '87. So in those 50 years, Sir Francis had witnessed the arrival of antibiotics, effective treatment for tuberculosis, and the antipsychotics, which transformed psychiatry. Polio, which caused a devastating epidemic in my own city of Cork in the 1950s, became preventable by vaccination. The WHO declared the eradication of smallpox in 1980. Compared to vaccination, organ transplantation has had a much smaller impact on global health, but was viewed by the public as one of the great triumphs of scientific medicine. There was the discovery of the double helix in the early 50s. Flexible endoscopy arrived in the late 50s, cardiac bypass surgery in the 60s, CT scanning in the 70s, and so on. So this was a once-off in human history, a unique confluence of science, serendipity, and events. And I think we tend to forget what medicine and life was like before this golden age changed everything. I want to show you a photograph of my mother's family taken in 1946. The occasion was the final profession of my Aunt Julia as a Loreto nun. She died 2 years ago at the age of 94. Now, in the back row, third from the left, is the youngest son, Billy, age 17. And you can tell from this photograph that he's not well. He died the following year of spinal tuberculosis. He died at home because medicine had little or nothing to offer. Less than 2 years after Billy's death, the British Medical Journal, the BMJ, published the very first ever randomized controlled trial. And this trial showed that streptomycin was effective against pulmonary tuberculosis. The trial was designed by the great statistician Austin Bradford Hill, and it was run and funded by the Medical Research Council. There was a dramatic rise in life expectancy during the Golden Age, particularly in Europe. But this change was well underway before the Golden Age. So not all or even most of this gain was due to progress in medicine. Nevertheless, there was a confidence that the same rate of progress would continue indefinitely. Here's the late Professor Risteard Mulcahy, cardiologist at St. Vincent's Hospital. In 1987, he gave an interview to the Irish Times, and he confidently predicted that by the year 2000, heart disease, stroke, respiratory disease, and cancer would be wiped out. Since the mid-1980s, there certainly has been progress, but when compared to the triumphs of the Golden Age, progress in my professional lifetime has been mainly incremental. Many would say that the low-hanging fruit had been picked during the Golden Age. Dissenting voices within medicine were rare during the Golden Age, but one was Sir Macfarlane Burnet. Burnet was an Australian Nobel Prize-winning virologist and immunologist. He caused a sensation in the early 70s with his book, Genes, Dreams and Realities. In this book, he argued that the golden age of medical research was drawing to a close and that the triumphs of laboratory science were coming to an end. He predicted that the diseases of the future would be those of old age and degeneration, and that these diseases would not be conquered like the infectious diseases were during the Golden Age. Burnet shared the Nobel Prize in 1960 with Sir Peter Medawar. They won the prize for work on tissue grafting and acquired immunological tolerance. I should stress that they worked independently. Medawar was appalled by Burnet's book and wrote about it some years later for the New York Review of Books. And he predicted that within a decade, multiple sclerosis, diabetes, and two common cancers would be cured. History sided with. So why was there so much progress during these 50 years? This is Vannevar Bush, Dean of Engineering at MIT and head of the Office of Scientific Research and Development during the Second World War. And all military R&D went through this office. President Roosevelt recognized that science had been crucial to the war effort, and he wanted the lessons learned to be applied to the development of science in peacetime. Bush's 1945 report, Science, the Endless Frontier, emphasized the primacy of basic research and government funding. And this report was incredibly influential on US government policy and led to a huge expansion in scientific research at American universities and a tenfold increase in government funding from the 40s to the 60s. In Britain, the 1944 Good Enough report on medical education recommended that every medical school should be a university medical school. This led to a major expansion in the number of academic medical posts, although there wasn't quite the same dramatic rise in government funding of research. Good Enough, by the way, was a banker, chairman of Barclays. In his final address to the American nation, President Eisenhower coined the phrase the military-industrial complex and warned against its growing power and influence. And so too, in the post-war years, a medical industrial complex emerged as well as a military industrial complex. And this complex has many stakeholders, including the pharmaceutical industry, manufacturers of medical devices, insurance companies, pharmacy sector. Sales of health foods are increasing exponentially. Large research institutions, journals. The big tech companies are investing heavily in healthcare. The NHS in particular has provided rich pickings for investors through PFI schemes. Healthcare provides a lot of work for lobbyists and management consultants. And as we've seen in this country, medical education is now big business. The intellectual motor of the medical industrial complex is research. And all this research has to go somewhere, and that somewhere is a journal. The production of research, published research, has multiplied several-fold in my professional lifetime, and this graph shows the ever-rising number of papers listed on PubMed every year. I want to tell you a little bit about Robert Maxwell, because his story is crucial to the development of scientific publishing in the post-war years. He was a Czech-born business tycoon, father of Ghislaine, who's very much in the news at the moment, and here she is pictured next to him. Maxwell famously emptied the pension fund of the Daily Mirror workers and died in 1991 in very mysterious circumstances. Maxwell made his first fortune out of scientific publishing. He called it a perpetual financing machine with a unique business model. The product, that is scientific papers, is given to the publishers for free. Other researchers do the editing and reviewing for free. The purchasers of the product are mainly government-funded institutes and universities. So it's a bizarre triple pay system in which the state funds the research, pays the salaries of those producing it and those checking its quality, and then buys the finished product. Maxwell figured out pretty quickly in the 50s that the universities and research institutes would subscribe to every new journal he started, and he had no difficulty persuading academics to edit and contribute to them. Scientific publishing is somewhere between the film and music industries in size, but what is truly remarkable is the profit margin. Elsevier, the biggest scientific publisher, has a profit margin of 40% on turnover, vastly greater than other industries such as car manufacture. Robert Maxwell would have admired the pure shamelessness of the predatory journals. They emerged, as most of you know, about 10 years ago, and they emerged to meet the need of researchers to publish their work. Predatory journals will publish anything as long as you pay. Their number has risen exponentially in the last 10 years in particular, and they're now thought to be somewhere between 8,000 and 10,000 of them. I receive emails from them every day inviting me to contribute or join their editorial board. We've even seen the emergence of predatory conferences. So by the mid-1990s, there was a growing unease within medicine that research was losing its way. And over the next 2 decades, this unease gradually transformed into a kind of moral panic. A paper published in the BMJ in 1994 was a turning point. It was written by the great statistician Douglas Altman and called The Scandal of Poor Medical Research. Altman articulated clearly and concisely what everyone within medicine knew, which was that much poor research arises because researchers feel compelled for career reasons to carry out research. They're ill-equipped to perform and nobody stops them. This editorial had a major impact. In 2015, the British Medical Journal held a poll of its readers as to which paper the journal should be most proud of publishing over the previous 25 years, and this paper won by some distance. By the early 2000s, a new discipline called meta-research emerged. That is, research about research. And it is, rather ironically, one of the most rapidly expanding fields of scientific endeavor. One of its founders and leading lights is John Ioannidis, a Greek-American professor at Stanford. And he has been critically appraising medical research for over 2 decades. His 2005 paper, Why Most Published Research Findings Are False, is the most cited paper ever published by PLOS Medicine. Ioannidis coined the phrase the medical misinformation mess. This mess, he said, has 4 components. Much research is unreliable, offers no benefit to patients, and is not useful to decision makers. Most doctors are unaware of this. Even if they are, they lack the skills to critically evaluate evidence. And patients and families often struggle to access good evidence and skilled guidance. 4 years later, in 2009, okay, getting back to where we were, I was talking about the Lancet paper in 2009, written by Ian Chalmers and Paul Glaziou. This paper was called Avoidable Waste in Medical Research. And this had a major impact. They identified 3 causes of waste: incomplete reporting, half of registered trials are never published in full; poor reporting, half of all published trials are not sufficiently clear, complete, or accurate enough for others to use; and poor design, half of all new studies do not take systematic account of lessons from previous research. Now, they came up with a figure of an annual waste of $170 billion. They used the analogy of a transport business where half the goods are badly designed, half are lost in shipping, and half of the remainder are broken by the time they arrive. Now, many commentators took issue with this figure of 85% and $170 billion, but there was an overall consensus that there was a major problem with waste in medical research, and this paper made a big impact at the time. 3 years later, Ben Goldacre published Bad Pharma, in which he very eloquently explained how industry had essentially hijacked evidence-based medicine. Most trials are industry-sponsored, and it's hardly surprising that industry has ensured that they get the correct result from such trials. And Ben Goldacre concluded that the entire process had been systematically corrupted. Even pharma itself began to get worried. Glenn Begley is an Australian academic hematologist and oncologist who wrote a now famous paper for Nature in 2012. Begley had left academia after 25 years to go and work for Amgen in Southern California, and he worked for 10 years with this company. During that time, he and his team scoured the literature for leads to new cancer drugs. And if something looked promising, the Amgen scientists would repeat the experiment to see if they came up with the same result. And most of the time they couldn't. So before he left Amgen, he took stock of 53 studies his team had filed away as not reproducible. He contacted the academic scientists who had carried out the original work, and most of them agreed to cooperate. And if Amgen couldn't reproduce the original result, they tried again. On 20 occasions, they sent company scientists, Amgen scientists, to the host lab and watched them perform the experiments again. Out of the 53 original studies, only 6 could be replicated. Amgen's directors encouraged Begley to publish his findings, which he did in Nature. He decided he would be more credible with an academic co-author and wrote this paper with Lee Ellis from the MD Anderson Cancer Center in Houston, Texas. Less than 2 years later, early in 2014, the Lancet published a big series of articles on waste in medical research. And the authors included, as you might expect, people like John Ioannidis, Ian Chalmers, and Paul Glaziou. They identified 5 steps that lead to waste: irrelevance. Much research fails to address questions that matter and doesn't take account of previous work. Poor design. Many studies are too small or fail to deal with bias. Poor regulation. Medical research is both badly regulated and over-regulated. Inaccessibility. Half of studies are not published at all, and there is a bias in what is published towards those that are positive. And finally, biased reporting. Published papers are often biased and unusable. Half of all study outcomes are not reported. Richard Smith was editor of the British Medical Journal when Douglas Altman's famous editorial was published in 1994. And in 2014, the BMJ wanted to mark the 20th anniversary of Altman's paper, and Risteard wrote a commentary on it. And this was around the same time that this Lancet series on waste and research came out. So Risteard wrote a piece for the BMJ called Medical Research, Still a Scandal. He lamented that little had changed in the 2 decades since Altman's paper, and that this 20-year-old paper could be published in 2014 pretty much unchanged. While Altman thought that the problem was caused mainly by amateurs dabbling in research, Smith argued that it was caused by career researchers who were more interested in funding than truth. In 2007, Risteard wrote a book called The Trouble with Medical Journals. Now, when somebody who has edited a major journal like the BMJ for 16 years writes a book with a title like this, you tend to sit up and take notice. I will just read the final paragraph of this book. Medical journals have many problems and need reform. They are over-influenced by the pharmaceutical industry, too fond of the mass media, and yet neglectful of patients. The research they contain is hard to interpret and prone to bias. Peer review is deeply flawed. Many studies are fraudulent, and yet the scientific community has not responded adequately to the problem of fraud. Editors also misbehave. Authors often have little to do with published work, and many have conflicts of interest that they do not declare. The whole business of medical journals is corrupt, and this matters because journals have a strong influence on healthcare. Strong stuff. The moral panic continued to grow. The following year, in April 15, a symposium on what was now called the replication crisis was held in London under the collective auspices of the Academy of Medical Sciences, the Biotechnology and Biological Sciences Research Council, the MRC, and the Wellcome Trust. The report on this meeting, which arrived 6 months later, concluded that there is no single cause for this crisis. They listed the usual things: bias for positive studies, p-hacking and data dredging, harking, hypothesizing after the results are known, weak experimental design, including poor statistical power. By the way, there was a physicist at this symposium who thought that the p-values which biomedical scientists regarded as significant would be laughable in his field of particle physics. The most important factor that they identified is what might be called cultural, namely the hyper-competitive environment in which researchers now work. And this environment is full of perverse incentives. These incentives have had particular consequences for the ecology of scientific communities. Richard Horton, the editor of the Lancet, who's had quite a high profile during COVID, took part in the symposium and shortly after lamented in his own journal that something has gone fundamentally wrong with one of our greatest human creations. In his editorial, he wrote, "The conclusion of the symposium was that something must be done, but as to what to do or how to do it, there were no firm answers. The good news is that science is beginning to take some of its worst failings seriously. The bad news is that nobody is ready to take the first step to clean up the system." A few months later, another international symposium called Improving Biomedical Research was held at the Metrics Center for Meta-Research at Stanford, which was run by John Ioannidis and Stephen Goodman. They focused on 4 approaches to fixing the broken system: getting scientists to change their ways, getting journals to change their incentives, getting funders to promote better practices, and getting universities to grapple with these issues. They concluded that the first would be the most difficult. This brilliant paper, The Natural Selection of Bad Science, was published in the Royal Society's journal Open Science in 2016. The authors are Paul Smaldino, a cognitive scientist, and Risteard Mulcahy, a behavioral scientist. And they used a Darwinian evolutionary model to explain how bad science has prospered. They argue that natural selection of high volume published output spreads bad science because successful labs produce more progeny who are more likely to start labs of their own. Writing in Nature that same year, Mario Biagioli, who was professor of law and science at the University of California, wrote about gaming of publication metrics, and he laid the blame for this squarely with the universities. He wrote the audit culture of universities, their love affair with metrics, impact factors, citation statistics, and ranking doesn't just incentivize this new form of bad behavior, it enables it. So we know what the problems are. We even have a rough idea how to address them. So what's been happening? There have been countless initiatives, new organizations and declarations. We have the Reward Alliance set up by Paul Glasziou to keep the momentum of the 2014 Lancet series going. There's the EVER Forum, short for Ensuring Value in Research. There's the All Trials campaign, spearheaded by Ben Goldacre. There's the Evidence-Based Research Network. There's the Equator Network, enhancing the quality and transparency of research. There's the Consolidated Standards of Reporting Trials consort. We have DORA, the San Francisco Declaration on Research Assessment. We have the Leiden Manifesto. Both of these oppose the hegemony of publication metrics. There is the Declaration to Improve Biomedical and Health Research from the Center for Open Science. And there are many other such well-meaning, somewhat pious initiatives and declarations. But the problem is this, which was neatly encapsulated in an article in The Conversation recently by two researchers affiliated with that previous declaration, Kelly Lloyd and Stephen Bradley. They wrote, the question isn't what are the solutions we can use to fix research waste, but instead, why aren't these solutions being used? And another major challenge is that each area of biomedical research has its own distinct subculture with its own unique problems. So far, I've concentrated or spoken on problems which are essentially problems of process, but I believe that these are a symptom of a deeper cultural and intellectual malaise. In 2014, 4 leaders of American biomedicine collaborated on a paper for Proceedings of the National Academy of Sciences, and the paper was entitled Rescuing US Biomedical Research from Its Systemic Flaws. The authors were from the left, Shirley Tilghman, molecular biologist and former president of Princeton; Bruce Alberts, biochemist and former president of the National Academy of Sciences; Harold Varmus, Nobel laureate, cancer biologist, king of American biomedical research; and finally, Mark Kirchner, chair of systems biology at Harvard. Not a single clinician there, you will notice. Unlike the Lancet series of papers, they were more concerned with cultural issues. They wrote that biomedical research in America is on an unsustainable path. They attributed this to the hyper-competitive grant system and job market. They made several recommendations. First, that the number of PhD students and postdocs be reduced and replaced by permanent staff scientists. Second, that researchers should be funded on the overall quality of their work rather than for specific projects. Third, that we should stop using publication metrics when appointing or promoting scientists. 4 months after this paper was published, the authors convened a meeting of representatives from the universities, government agencies, scientists and students, and the meeting ended in discord. I quote from their paper, "Little has been done to transform the system because it continues to benefit the most established and influential scientists." Now, I'd like to tell you now a story of how research in my own speciality of gastroenterology changed in Britain, where I spent 14 years working and training. This change was not planned or foreseen, and it's an instructive little story that tells us something about how perverse incentives can drive bad research. Back in the late 1980s, I went to work as a research fellow because to progress in my career in gastroenterology, I had to have an MD and as many papers as possible. Now I can't point, but I'm there in the back row, 1, 2, 3, 5th from the left. This is 1988 when I worked as a research registrar in Edinburgh. Now in those days, there was intense competition for senior registrar posts. And this was the major career bottleneck. Once you got through this, you were pretty much guaranteed that you'd eventually get a consultant post. However, some people after several years at registrar level in the specialty failed to get through this bottleneck and had to go into something else. But a strange thing happened in the early 1990s. The academic portion of the CVs of candidates for consultant gastroenterology posts in Britain got lighter and lighter. In the early 90s, candidates for these jobs had an average of 20 papers in their CVs. A decade later, it had fallen to 2. So why did this happen? Did hospitals and senior doctors suddenly come around to Douglas Altman's view? No, it was down to 2 unforeseen events. This is Kenneth Coleman, a Scottish oncologist, and he was Britain's chief medical officer for most of the 1990s. His major legacy is what has come to be called Calmanization, which is a pretty awful word which was coined to describe his abolition of the senior registrar grade and its replacement by that of specialist registrar or SPR. And the same happened here in Ireland. SPRs were appointed straight from basic junior training to a 5-year specialist scheme culminating in a consultant post. And there were many more SPR posts than senior registrar posts. So the need to fill your CV with publications pretty much disappeared. The second event was the establishment of the purchaser-provider model by Margaret Thatcher's Tory government. This created fund-holding GPs who wanted a lot of endoscopy doing. This created a demand for gastroenterologists, and this led to a decline in competition for these posts. So the incentivization of research by trainee gastroenterologists disappeared. There are many historical examples of perverse incentives, most famously the Cobra story. During British rule in India, the government offered a bounty for dead cobras, hoping to reduce the population. Some enterprising people began to breed these snakes. And when the authorities became aware of this, they scrapped the bounty. The cobra breeders then released the snakes into the wild, thus increasing the population. The British academic gastroenterology establishment viewed the decline in papers published by trainees as a major problem, even a crisis. But it wasn't. Most of these papers were of poor quality, written to advance careers. They were not a loss. I quote yet again Douglas Altman, "The length of a list of publications is a dubious indicator of ability to do good research. Its relevance to the ability to be a good doctor is even more obscure." So 90% of these papers disappeared. The 10% which stayed were done by the minority who actually wanted to do research. Now, old fogey clinicians like me tend to be dubious about the contemporary consensus that breakthroughs in medicine will come predominantly from molecular research carried out in big institutions. Now, I want to look briefly through my rose-tinted spectacles. And in the past, many major advances were achieved by people working in small groups with little institutional or financial support. Peptic ulcer was the dominant theme in that collection of papers I showed you gathered together by the British Society of Gastroenterology in 1987. And the riddle was solved by an Australian pathologist called Robin Warren, he's the one with the beard, who noticed these funny bacteria in gastric biopsies from ulcer patients. He recruited a registrar called Barry Marshall because he needed an endoscopist to supply him with tissue. They won the Nobel Prize in 2005 for establishing Helicobacter as the cause of peptic ulcer. Patrick Steptoe was on the left, was an obstetrician based in Oldham, about as unglamorous as it gets. He worked with the physiologist Robert Edwards to develop in vitro fertilization. They worked on a shoestring. The MRC refused to fund them on ethical grounds. Steptoe died in 1988, and Edwards was awarded the Nobel Prize in 2010. Major advances in my speciality of gastroenterology often came from other disciplines, non-medical disciplines, particularly physics. Harold Hopkins was a physicist at Imperial College whose work on fiber optics made endoscopy possible. And other major advances were often down to clinical adaptations of existing technology, not science as such. Peter Cotton was still a senior registrar in 1970 when he heard about a Japanese surgeon who had cannulated the bile duct with an endoscope. Cotton went out to see him and came back to London with ambitious ideas. Over the next few years, he developed this technique, ERCP, endoscopic retrograde cholangiopancreatography. It's a standard intervention for many decades for the removal of bile duct stones and stenting for cancer. Now, anyone with good hands and a technical bent can develop a procedure. But what I admired about Cotton, who's now in his 80s, is the scientific rigor that he brought to the analysis of clinical outcomes with this procedure, particularly complications. He was an enthusiast, but not a boosterist. And over nearly 5 decades, he championed quality assurance, appropriate use of the procedure, and proper training in how to do it. Towards the end of the golden age, in 1987, the great American epidemiologist and clinician Alvin Feinstein warned against the increasing dominance of molecular medicine. In 1987, he warned that preclinical sciences have become detached from their clinical origins and have goals that often have no relationship to clinical medicine. So too, David Sackett, who's often called the father of evidence-based medicine. He complained in the BMJ in 2004 that basic medical scientists had hijacked the granting bodies. And even the great panjandrums of molecular research admitted to some disappointment. Here's Robert Weinberg of MIT, famous cancer biologist, discoverer of the RAS oncogene. He wrote what I can only call a confessional essay for the journal Cell in 2014, in which he conceded that the molecular approach had not delivered the breakthroughs expected. He wrote, "The data that we now generate overwhelm our abilities of interpretation, and the new discipline of systems biology has produced few insights into cancer." It's just over 20 years since Bill Clinton told the world that the Human Genome Project would revolutionize the diagnosis, prevention, and treatment of all human disease. I don't deny that the project was a major achievement, but I think it's fair to say we're still waiting for that revolution. A little closer to home, this man, William Campbell, is our only Nobel laureate in medicine. And he shared the prize 5 years ago for his work on the eradication of river blindness, a parasitic disease. He published a memoir this year called Catching the Worm. And he wrote in this memoir, as molecular biology emerged, the trend moved away from empirical research. It was seen as old hat. He pointed out that ivermectin, the drug for which he had won the Nobel, was the product of empirical screening. You'll be familiar with Moore's law, namely the observation that the number of transistors in an integrated circuit doubles every 2 years. Eroom's law, which is Moore spelled backwards, is the observation that the cost of developing a new drug doubles every 9 years. In January of this year, just before COVID broke, the WHO warned that the lack of new antibiotics threatens global efforts to contain drug-resistant infections and is now a crisis. All of this feeds into an intellectual movement which might be called declinism. The American commentator Ross Douthat, whose book The Decadent Society came out this year, argues that the rich societies of the West have stagnated economically, politically, culturally, and intellectually, that they are decadent. Meanwhile, people in low-income countries die of diseases that can be cheaply cured and prevented. They also die without adequate pain relief or palliative care. 3 years ago, in 2017, the Lancet published a report produced by a commission that they had brought together. And this report was called Alleviating the Access Abyss in Palliative Care. And this report described how 25 million people every year, that's 45% of all deaths throughout the world, 25 million people every year experience severe suffering at the end of life. Poor people throughout the world die without access to opiates, let alone palliative care. Richard Horton wrote this powerful editorial to accompany the Commission's report. And he wrote, "Medicine regards the alleviation of suffering as someone else's problem. Palliative care is too often seen as a failure. The hubris of modern medicine is that it cannot face up to failure. The deification of biomedicine has created an anti-humanist and quasi-theocratic science of health." I'm a member of another Lancet commission on the value of death, which is due to report early next year. I accepted the invitation to work with this commission because I believe that medicine has gone wrong in the way it deals with death. Before he died in 2018, Douglas Altman remarked that not much had changed since his famous 1994 paper, and he joked that he was planning to write another one called The Continuing Scandal of Poor Medical Research. I couldn't improve on his simple formula. We do need research, but we need less of it. We need better research, and we need research done for the right reasons. It would be impossible to talk about research without mentioning COVID. As yet, we don't have an effective antiviral agent. We don't have a vaccine. What we do have, however, is a vast production of data. We are almost choking on it. I picked at random Helicobacter on PubMed, and which has been the subject of research for 4 decades. And here's COVID comfortably outperforming it after a mere 7 months. The statistician Sir David Spiegelhalter is particularly irritated by the phrase, "beloved of politicians, we must follow the science." He said recently in the Times, "You do not follow science because science doesn't tell you what to do. Science is sitting beside you, humming and hawing." We seem to have forgotten that in science, doubt is our greatest ally. After my second book was published last year, I got a lot of emails and letters, and some of them, in fact, many of them came from people who practice alternative medicine and also people who are opposed to vaccination. And they assumed that because I had written a critique of the medical industrial complex, that I must therefore share their worldview. And I wrote back to explain that, no, I believe in science, I believe in the scientific method, that I support good science. But science is under attack. And if science is to withstand this onslaught, it must put its own house in order. The challenge, as I said, is not identifying technical fixes. The challenge is much harder, to change the culture and the structure of biomedicine so that scientists don't have to choose between their careers and doing it right, between ambition and delight. The purpose of medical research is to improve the health of people worldwide and to find better ways to treat and prevent disease. It is not there to create jobs and to drive the economy. We talk of scientific medicine, but nobody uses the term scientific physics, do they? That's because medicine is not a science, it's a craft, it's a practice, which looks to science for guidance. But we now seem to have 2 cultures in medicine. The gap between the clinicians and the scientists has become a chasm. And even the word translational is a tacit admission that we speak different languages. So what is medicine for? Many of my heroes are statisticians. They're my kind of scientist. Major Greenwood was professor of epidemiology and statistics at the London School of Hygiene and Tropical Medicine. And he was mentor to many, including Austin Bradford Hill. Greenwood gave a speech in 1931 in which he laid out the ethos of his school. He said, the ambition of the school is to become the spiritual home of men and women, all aspiring to do their part to make the conditions of human life everywhere more bearable. And I find this humble aspiration rather moving. And I believe that is what medicine is for, and it's also what